are going to determine that. We are going to determine. Adam? Yes? Huh? Now, what is the question?
Determine the momentum of a cheetah of mass 45 kg chasing an antelope at 10 meters per second.
What are we going to do? First do what? First summarize. They give any data. We have what? Mass. Mass is equal to what? 45 kg. What else do you have? Velocity. Velocity is what? 10 meters per second. What am I going to do now? We are going to multiply, yeah? We say momentum is equal to mass times velocity. Let us substitute and we get the final answer. Let us substitute. Substitute and you work about that. 450 what? Kilograms meter per second. 450 kilogram meters per second, yeah?
Yes.
Yes. How are you done? We are going to box another one. Another example. What should you do?
A car of 1,500 covered at distance of 100 meters in 2.5 seconds. Find its momentum.
Find its momentum. Let us go to that. Find its momentum. Further. Are we done?
No.
Use the TP and the green background. Go and you get the TP. What is our final answer? The law of conservation of linear momentum states that provided no external force. How is on page 23 here? I'm reading page 23 where there is not up there. Provided no external force acts on a system. Provided no external force acts on a system of colliding bodies. You are going to get to know what we call collision of colliding bodies. Velocity. We're going to act on a system. Say that it acts on what? A system. Acts on what? A system. That is not heading. What is collusion? Right, collusion collusion, and give me some of the type of collusion. And some examples. Some of the examples of collusion. Collide where? Lucky bed, quality, layers, another one. Car accident, dead, another one. Collusion. Very young with the man. So many cars. Then you collide there. Let's bring that one here. I don't use now thinking that one where you collide this. Let's bring that one. I don't much you collide and you got an accident, you're going to buy that. Another one is where? There are some where they collide and separate. There are some where they collide and move together. And those are what we call the two types C. You give us the type C. Yeah. Elastic collusion. We have what we call elastic what? Collusion. Elastic collusion. Another one. We have what? We have inelastic collusion. Then we have inelastic collusion and elastic collusion. We are going to get to know some of the examples under that. When you talk about elastic collusion, what is elastic collusion? Nobody understand. What is elastic collusion? Elastic collusion. Anybody tell us how long you need to take to go inside? Come when you are ready for the lesson. Rather than just think. We are going to work at another group now. I just give you assignment. Your group come and present like that. Rather than being there as if you are, hey, yes, woman.
Separate after collusion. After collusion, with different elastics.
With different develop. They are going to separate after collusion. So we are wearing sweaters, jumpers. Remove the jumpers. Because I don't want to somebody come to my lesson. This time, the way you play deliver. One game, if the minister comes and says something towards you, you go forever, you come back next year. My lesson. Unless you have a problem. And this says, medicine is going to come. Examples, we have what? Some of my examples where the body is separate after collusion. Separate after what? Collusion. We are very what? Very food. You know play? You know that they used to play food? On pool table, hammer. They know the other one. They did separate. Separate. Another one. Food. So they know these things. Where are they going to separate? Our daily life. Good one. Good one. We have what is? We have also what we call ideal gas. You know ideal gas? When you talk about gases, gas molecules, they know one and Séparé. Air molecules. Air more. In this cylinder, what happened? This one knocks this. That one, they are going to separate. After polarity. That is what we call inelastic. Let us say collision. We are writing something down. What is collision? Who can give us a definition? Is when two or more bodies come into contact. Right, that is the definition of pollution. Types of pollution. Types of what? Come to conductive. That is the definition. From there, we say that types of pollution. There are two types of pollution. There are two types of pollution. There are two types of pollution. There stand. Moving in your jumper. I see money that what about afternoon? Yeah, I really said now, if you're not stable, we're going to see, don't go to the rest from your going to the other last. Now we're going to take the example. People will become more serious. It's not yours. You can stand there. You go with your book. Where's your shoe? Where's your shoe and mine? Huh? Take one. Take one. Nice, take one. Now, one. Now, class captain. Class captain, put your hand on this. Bring my cup. Listen, bring. We start using our whatever. If you don't have a shoe, please. Just stop playing. We're in charge of this. As if we are. If I wear this and I come inside the class, how do you feel? See this yourself. See, yes. Need to become more serious. Why go you see? Why don't you see generation you are going to suffer? That is now to study. Be in the other class. Watch each and everything. You watch each and every what? If you are not serious. Let us begin with the elastic collision. Elastic collision. You want to summarize and you go for the other practice, whatever. Elastic collision. is attentive, right? Elastic collision. Madam said what? This is the type of collision. This is the what? Type of collision. This is the type of collision where they collide. Where the colliding bodies. Where the colliding bodies. Now you are moving those where the colliding bodies separate after collision. Separate after collision. Separate after collision and move with it. And move with it. And move with the different velocities. And move with the different velocities. And move with the different velocities. And as that we say, both momentum and kinetic energy. 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 Both momentum and kinetic energy are conserved. Both momentum and kinetic energy are what? Are conserved. Are conserved. We say, consider two bodies. Consider two bodies. Consider two bodies. Consider two bodies. Consider two bodies of masses M1 and M2 moving with the initial velocity. Initial velocities. So don't come back. Initial velocities U1 and U2 respectively. After collision, they move with the final velocities. They move with the final velocities V1 and V2 respectively. We are now getting the formula where the moment they talk about elastic collision. And a live example of this, we try to they try to give me the examples of elastic collision, where you talk about the ideal gases, where you talk about those the balls of the pool table. When you are playing there, the ball knock another one, they separate, and they move with different velocities. Here we have this before collision and after collision. We are accumulating the formula where we are going to use. We say from the principle of conservation of linear momentum. That word linear means that the body must move in a straight direction. Moving in a straight path, that is linear. We say the total momentum before collision is equal to total momentum after collision. We have our M1 U1 plus M what? U what? Is equal to M1 V1 plus what? M2 V what? V2. I did this. What? Don't worry. Moment you move out and your solution don't get it, you come back in our lesson.
Yes.
Because you are going to disturb your friends. What's your name? Say that again. This is Sadiq of 1999. Before carrying out an example, we are going to also talk about the The other part of, remember we said that both kinetic energy and the momentum are what? Are conserved. The other side of kinetic energy, this is momentum. When we talk about kinetic energy, for kinetic energy, here there is no loss of kinetic energy because they are going to separate after group. Total kinetic energy before collision is equal to total KE after what? After collision. Here we have a half M1 U1 squared plus a half M2 U2 squared is equal to a half M1 U1 squared plus a half M2 V2 squared. That is the formula of the kinetic energy. This implies that there is no loss in kinetic energy. If we try to calculate the kinetic energy of the before collision and kinetic energy after collision, they are going to be the same. This implies that there is no loss in the kinetic energy. If there is a loss in the kinetic energy, we are going to experience in the elastic collision because the speed of the two colliding bodies is going to be reduced. When you try to have a aeroplane like this at a table speed, remember that speed when you are together is going to be reduced. That one which is such a way there because you try to catch your friend. When you try to catch your friend, automatically you and your friend, the speed is going to reduce. That is what we call in elastic collision. With the what? Common velocity. And some of the examples you give me that we have head-to-head those vehicles. In Iraq, we talk about also in rugby hugging someone like this. Now your common velocity is going to be what? It's going to be uniform, and the speed is going to be reduced. Let us move to any elastic collision. Any elastic collision. Any elastic collision. Any what? Any elastic. Any elastic. Who's giving us the definition? What is inelastic? Yes, madam. And with the same velocity, they try to stay together after collision and move with the same what? Velocity. Let us write that. You write that. I want to see the way you try to phrase. I want to see the way you try to what? To phrase that. Phrase the definition. Place the what? The definition before. Let's phrase the definition. You phrase the definition before we move. Are you done? Tugambye what is the type of what? Is a type of collision where what? Is a type of collision where the colliding bodies they stay together after what? After collision. And what? And move with the same velocity. And move with the same velocity. And they move with the same what? Velocity. On your line we say the momentum is conserved. The momentum is what? Conserved. The momentum is conserved. The momentum is what? Conserved. But what? But kinetic energy is not what? But kinetic energy is not what? Is not conserved. But kinetic energy is not what? Conserved. Full stop. The reason why this kinetic energy is not conserved, there is a loss in kinetic energy. What brings this loss? What caused the loss of kinetic energy? Here, our kinetic energy, since the body is under the motion, some of the kinetic energy is going to be converted into heat. Energy. It's like when you knock with your friend head to head. That pain, my clear, is like a loss of the kinetic energy. And another one, some of the kinetic energy is going to be converted into sound energy. Sound. When the two bodies they are under what they are in the impact, they collide one another, there is a sound. But it's due to what? This kinetic energy, because the bodies are under in motion. Let us consider two bodies of mass. Consider two bodies of what? Of mass. Consider two bodies of what? Of mass. M1 and M what? M1 and M2. M1 and M2. Moving with the initial velocity U1 and U what? U2. Moving with the initial velocities U1 and what? You two respectively. Full stop. After collision, they move with the same velocity. After collision, they move with the same velocity. With the same velocity v. After collision, they move with the same. Come in. Okay, give me. Are you there? Are we there? Manji?
Yes.
Now, what are you going to do?